Thanks for coming. We know it's crazy time to be at a session. It's 5:30 in Las Vegas, and I was just walking down by the elevators, and a couple of guys asked me, am I heading to some party? And I'm like, no, I have a session to do now. So thank you, actually, for coming today. And my name is Aarti. I'm a partner solutions architect with AWS. Been involved in the VMware Cloud on AWS project for a while now. And this is Wen. He's my partner in crime. I'll let Wen introduce himself.
Hi, folks. Good evening, and thank you again for coming. I know we are between you and the dinner party that you have planned for. To appreciate you coming in, we have some swags. Unfortunately, we don't have enough for everyone. What we'll do is we'll have questions about the content that we share with you. So we start with this section here, and then the next question back there, third question over there. So we have a nice hat with a speaker pin and 2 shirts, okay? Have a good time. We'll try to keep the session entertaining and get you out of here on time. And back to you, Aarti.
Thanks, Wen. So I hope everybody attended the keynote this morning, and Andy and Pat announced the initial availability of the VMware Cloud on AWS service. We are super excited, and we hope at the end of the session you take back information so that you can get started with the VMware Cloud on AWS. The standard disclaimer, I'm sure this is your 15th time of the day. I'm not going to go over it. So before actually moving into the networking and storage best practices, we thought we'll walk you through how the onboarding experience is going to look like. The product is now initially available, and we thought we'll walk you through what a customer's journey is through the onboarding experience. So with the service itself, there's 2 accounts involved. One is the VMware Cloud on AWS SDDC account, and the other is the customer AWS account. The SDDC account is where the actual service will be running. This is an account that's owned and operated and paid by VMware. VMware pays the bill for the service there. This is a dedicated single tenant account. What this means is when, as a customer, you sign up for this service, VMware creates new dedicated account for every customer that signs up. And also, it's a single tenant, which means these are the hosts run on dedicated hardware. You're no longer sharing with other customers. The customer AWS account is a regular day-to-day AWS account that, as customers, you might already have. If you don't have an AWS account, as part of the onboarding experience, you will be required to sign up for an AWS account. This will allow you to seamlessly integrate with all the 90+ services that AWS has today. The connection between the SDDC account and the AWS account is done through a construct called Elastic Network Interface, which I'll dive deep in the networking architecture slides. So let's walk through how the creation of SDDC works. This is my VMware Cloud on AWS portal. I don't have an SDDC running, so this is the first page that I see. VMware has done a lot of heavy lifting. They've listened to customers, and they've done a lot of heavy lifting in this process where they want to make it as simple as possible. So the whole onboarding experience is broken down into 4 steps. The first step, we talked about these accounts, the SDDC account and the AWS account. The first step is actually connecting these accounts together. And then you define what SDDC properties you want. This is where you define how many hosts you would be needing and what region you would be needing the SDDC cluster in. At initial availability, the service itself is available in US West Oregon, but as Pat mentioned, by the end of 2018, it should be available in all AWS regions. So you could take the benefit of the AWS infrastructure here, choosing a cluster closer to your end location. The third process here is where you would select a VPC and a subnet for the connection, and we'll dive deep into this as we walk through the process. And last, and the optional step here, is configuring your management network for the ESXi hosts. So the first step here is connecting your accounts. So when I click the blue box there, basically what happens is VMware also displays detailed information for folks not familiar with the AWS ecosystem. What happens? So when you click that blue box that I showed you, you're taken into an AWS console where you would be asked to log in with your AWS IAM user credentials. Once you log into the AWS console, you'll be redirected to our AWS CloudFormation service page. what is AWS CloudFormation for folks not familiar? It's basically a service that AWS provides where you can launch and manage stacks of resources using templates. These are typically JSON or YAML. So what VMware has done here is they've taken the heavy lifting. So they've pre-populated a template that has a role and a policy attached to it. The policy has certain API permission calls that you as customers are giving VMware access. So as customers, you would run through the template and you would launch the stack. What the stack does is you're creating a role that allows VMware to have certain access into your account. For example, as customers, you would create logical networks at launch, or there might be use cases where you would be creating logical networks later. So for your services to talk to each other, when I mean services, let's say your EC2 instances to talk to your VMs, they need to know the logical networks. So one of the permission, for example, is updating your route tables in your VPC to add a route to the logical network. So when you add a logical network, you don't have to come and plumb into the route table to say, hey, I now have a new logical network that I need to plumb into my SDDC. So VMware takes care of that for you. So now I have my connection established. So I see my green checkbox. I have my connection established. The next step is where I would define my properties for my SDDC. So I have a four-node cluster here, and you could also see what the capacity of those nodes look like. Today, as I mentioned, it's available in US West, but eventually you will see a list of drop-down here for other regions that we will support. Once I define all my SDDC properties, I move into a subnet. And we're going to dive into this later as well. So I select a VPC in my VPC. As a customer, I would be selecting a VPC to terminate the connection point, and a subnet as well. So once I do that, the last step is pretty straightforward. This is an optional step, configuring your management network for the ESXi. If you don't want to do it, VMware is going to assume a 10.0.0/16 CIDR block. We recommend that you make sure you know what management network you want so that it doesn't overlap with your on-premise. So my SDDC is now created. It takes a couple of hours for the SDDC to get created. Meanwhile, we know that both VMware and AWS here want to provide a single pane of glass and also make it security as a super top priority here, which means VMware has a tab on their console that lets you see what role they assume into your account and what service it has access to. For example, here you would see the roles that VMware is assuming using the stack you launched, and also that you have access to the EC2. So throughout this onboarding process, there are a few key things to remember. The cross-account role that we talked about, that's the one that's actually establishing the connectivity between the AWS services in a VPC to your SDDC cluster. You have full control over this role. So you can, at any point of time, if you go delete this role, the connection is being terminated. Which also means all our AWS security services apply to that role. You could apply your security groups, you could apply access lists, you could monitor this using flow logs and CloudTrail, which is it's a service that tracks all your API activities into your account. So you could monitor any activity into your AWS account using this CloudTrail service. So we now have the SDDC up and running. We now need to connect to it. So there's multiple ways to connect into your SDDC. Of course, by default, there's a deny all on your firewall rules in your VMware Cloud on AWS console. So you could open up your firewall rules to allow connectivity from the internet and connect into your management gateway and your compute gateway. Of course, I'm here to talk about best practices, and I don't want you guys to open up your firewall rules to the whole internet. So the best practice that we recommend is setting up a layer 3 IPsec VPN connection from your on-prem device, terminating into the compute gateway and the management gateway. So now I now have 2 VPNs running from my on-premise device. VMware also has recommendations for phase 1 and phase 2 for IPsec, so we make sure that you follow the recommended settings. So we now have an L3 VPN connectivity. Let's see how the service works underneath now. On the left-hand side is where you see your customer data center. This is a typical data center with your VMware workloads and non-VMware workloads already running. And on the right-hand side is your VMware cloud on AWS. This is what we provisioned a few slides back. So this is our SDDC cluster with the ESX host running, with your management gateway and compute gateway, and then you have your VMs running on top of it. We went through this. So now I have connectivity using a layer 3 IPsec connection between my on-prem device and the management gateway and compute gateway. And the on-prem device could be any device. NSX on-prem is not a requirement. You could terminate it at any device that supports an IPsec connection. So I'm adding a new entity at the bottom. So we talked about the accounts. The one on top is your SDDC account. The one at the bottom is the customer AWS account. That's your account. So this is an account that customers already have today. And connecting to this account, there's, of course, multiple ways to connect into this account. You could use internet. You could use a layer 3 IPsec connection terminating into our, we call it a virtual gateway. It's a software construct on our side. It's typically a router where you terminate your IPsec connection. And also, you could use AWS Direct Connect. So AWS Direct Connect is our high bandwidth, low latency connection that runs between your data center to an Amazon POP location. It's basically a co-location, like a level 3 co-location. Yeah, I'm coming to that. Well, the connection to the bottom is typically, it's available today. That's regular customers do what they do today. What's not available at IA is Direct Connect integration into the SDDC is not available. So with the bottom connection is something that customers already, a lot of our enterprise customers that we talk to, they already have a Direct Connect established. With Direct Connects, there's two constructs, a public WIF and a private WIF. A private WIF is when you connect from your on-prem into a VPC. Everything is private IP addressing, it's RFC 1918 addresses, and BGP peering. With public WIFs, you would be using, if you need to talk to any of the other services using a public endpoint, S3 for example, or DynamoDB, you would be using a public WIF, and it is similar BGP peering, but it involves public IP addresses. So we have the whole connectivity from on-prem into the SDDC and from on-prem into the customer's AWS account. Now these are two different objects now. I need to have some kind of connectivity between these two. That's the whole value proposition where we say seamless connectivity between your VMware cloud on AWS environment and your already existing AWS environment. So what VMware does as part of the provisioning process is also they have permission to create network interfaces in your account in a subnet. This is the subnet you guys chose at the start when you go through the onboarding. So they create a subnet in your VPC and attach it to the ESXi host running in the VMware cloud on AWS. So this is a high bandwidth, low latency path, and it's all, the traffic still stays within the Amazon's backbone using the private IP addresses. So I now have a connection path between my VMware cloud on AWS account and my customer AWS account. So some use cases around the connection paths. Let's say I have a VM that wants to talk to an EC2 instance running in the subnet below. This could be an application instance, and they need to communicate to each other. So the way the network path is going to work is traffic from my VM flows through my compute gateway, reaches my ESXi. And as you guys know, we already have this one established. So when it comes to the Elastic Network Interface, Elastic Network Interface is a virtual interface. So it has a route table attached to it. And the way VPC routing works is by default, any VPC has a local route to the entire CIDR block. What it means is, let's say the customer VPC here has a CIDR block of a 10.0/16. You would see a route table entry that says local 10.0.0/16, which means any instances within this subnet know how to route to each other. So once it reaches the Elastic Network Interface, it looks at the route table there. It knows how to reach that particular instance in another subnet. And traffic for the from the instance itself to the VM follows a typical path. Your instance sitting inside the VPC subnet would look at its route table, and this is where what we talked about earlier, VMware manages the route table, so they automatically populate your logical network. So there would be an entry in the route table that says any traffic going to my logical network, use the next hop as my ENI, which is the Elastic Network Interface. So traffic from the instance itself goes through the Elastic Network Interface and goes all the way up to the VM. Another common use case that we see is internet connectivity. These VMs that are running need internet connectivity. And this is very straightforward. A typical VM, the traffic goes through the compute gateway, reaches the ESXi, and uses what we call an IGW. It's an internet gateway. The whole purpose of an internet gateway is to allow communication between instances sitting inside the VPC out to the internet. These are horizontally scaled, redundant devices that Amazon manages, so you don't have to worry about any bandwidth constraints or failures. This is a very interesting use case, and I know there's a lot of storage folks in the room as well. So Wen's going to be doing a lot of deep dive on this subject, but I'm just going to touch very briefly on how the network path is going to look like. So S3 today is our simple storage service, and we see a lot of use cases, and we hear a lot of use cases from our customers on how they want to use S3 for backup. There's multiple ways to connect to S3. And as you know, S3 is a regional service, so S3 is available in every region that we have today. So the same VM here, if I want to do a backup into S3, it will use my compute gateway, come into my ESXi host, and use the internet to talk to, let's say, the whole setup is in Oregon, and I want to talk to an S3 in Sydney today. It'll use my internet gateway and talk to Sydney. So this is one way of doing it. There is also another way of doing it. A few years back, customers told us, hey, it's fine, you guys have internet gateway, we could use the internet and talk to S3 in a different region. But if the S3 is in the same data center as the instances itself, doesn't it make sense for Amazon to provide us a way to do this within your private backbone? We listen to our customers. So we launched a construct called VPC endpoint for S3. It's typically the one that you see at the bottom here. What it does is, this is a construct like the internet gateway. We manage it. It's horizontally scaled. So traffic from the VM comes through my customer compute gateway, reaches my ESXi, and now has a route to the VPC endpoint. So the whole traffic path that you see here, this is all private. So it doesn't leave outside for the internet, and it still uses all the private IP addressing path that we have. And S3 today relies on prefix lists, so you will see a list of prefix lists on your endpoints. Some of the key considerations. So the route tables, I talked about it briefly. So VMware is going to be updating these route tables as you add new logical networks. And also, another key thing to remember here, we talked about these interfaces. These are the key connection point between both these VPCs. And VMware, when you look at these interfaces in your AWS console, you will see it tagged or described with VMware Cloud on AWS. Please do not go and alter this or delete this. It's pretty much going to terminate the whole connection path. I mean, things happen. You might have an IAM user who has no clue that you're running a VMware Cloud on AWS service, and he's cleaning up your accounts, and he deletes it. Feel free to contact VMware support and get that sorted out to make sure your connection still works. As we talked, VPC endpoints are available for connecting to S3 in a local region. Make use of it. It uses our private backbone. If you want to talk to a remote region, you will still have the internet gateway to talking to S3 buckets in a remote region. And with VPC endpoints, there's multiple layers of security that you can implement. There is identity and access management, and also bucket policies. Bucket policy will determine which VPC has access to a certain bucket. So you can control your security policies. Last but not the least, in order for all these connections to work, make sure you have your security group, which is similar to, for VMware folks, it is similar to your firewall rules that you configure. So we call it security group. So make sure you have the right rules in your security group configured. With that, I'll hand it over to Wen.
All right. Thank you, Arti. All right. Arti, walk us through the customer onboarding considerations as well as the network connectivity best practices. Now, for our first question to get a polo shirt, let's start with this section of the room. What should I ask? Okay, what's the minimum number of ESXi hosts that you can provision? All right, I'm just gonna throw it out, and I think you answer it first. Oh, that's a bad throw. All right, with that, we have 2 more swag to give away, and that will kick off the second half of today's session on storage services integration. We'll quickly highlight what each one of these services are, what they do, and then jump into a little bit about how they're integrated in the VMware Cloud on AWS solution. And then most importantly, highlight the top customer use cases that have been brought to our attention in our customer conversations and what we recommend to our customers based on what they ask us. Okay? Now, quick out of curiosity, how many of you know all about these services? Okay. Few of you. How about none at all? Okay, something in between is the majority. Okay, we'll spend about 15 seconds to introduce each service, and RT will keep me honest and keep me with the timer check. We want to spend most of the time talking about the use cases. Okay, so 3 main storage services integration with VMware Cloud on AWS, ranging from block storage to object storage to AWS storage gateway, and in particular, file gateway. Starting with block storage, we have Instant Store, as well as Elastic Block Store, also known as EBS. Object storage, RT mentioned Amazon S3, Symbol Storage Service. And last but not least, the storage gateway. We have variations of the storage gateway configuration depending on your use cases. And the focus here is on the file gateway. Doesn't mean the other types of virtual tape library or the volume or cache gateways won't work. It just, the most frequently asked ones are the file gateway, so we'll focus on that. And in terms of questions, I'm sure you have a lot of questions. Let's keep them towards the end. The mic over there doesn't work, so don't bother with that. So we'll come down here, let's come up here, and we can learn from you, listen to you. Okay, so towards the end, we'll stay for as long as your heart desires. With that said, block store services, 15 seconds on what each one is. Instant Store is locally attached, also known as ephemeral storage, for each and every compute instance running on EC2. And this is the storage that has no built-in replication for data blocks that are written to the devices. So vSAN does that. So this is the storage that's backing the vSAN disk groups. We'll get into the deeper architecture in the upcoming slide. The specific capabilities that are applicable to VMware Cloud on AWS solution are the following. They are backed by NVMe flash devices. So each compute instance has 8 total NVMe flash devices. Each is reported as 1.73 terabyte in the vSphere console. So 8 of them will give you approximately 14 terabyte of raw capacity for vSAN to create this group. And these devices have data encryption at rest by default with AES-256 XTS encryption and also built-in key rotation. So as a customer, you wouldn't have to worry about any of that. Now, that's Instant Store that is integrated with vSAN. We'll get into the details in the upcoming solutions architecture slide. Now, Elastic Block Store, EBS, is our block storage service. It is storage volumes in different types of offerings based on performance and capacity needs that could be attached to EC2 compute instances dynamically through API. So we deeply integrate with VMware ESXi hosts. In this initial version of the solution, EBS storage service is serving as the media for ESXi boot. So as a customer, that's something you don't have to worry about. You go on board the service, like RT mentioned, you go into the console, nowhere does it say EBS for your boot volume, because that's taken care of by the VMware team that's managing and operating the service. So you don't have to worry about, as a customer, the heavy lifting of, okay, let me make sure my SD card is mirror and make sure I have locally RAID configured for my local JBots. And that's something you wouldn't have to worry about again. Okay, now let's get into the details of the vSAN architecture. We mentioned EBS serving as the boot volume for ESXi, something you don't have to worry about. Now, vSAN is backed by Instant Store, the configuration is based on 2 disk groups. So in a given vSAN cluster, minimum of 4 hosts. Each host will have 8 NVMe devices, like I mentioned. The vSAN cluster will be pre-configured with 2 disk groups. So each disk group will have 1 write buffer, also known as caching tier device, for acknowledging the writes as they come in, and 3 capacity tier devices. So this vSAN cluster is pre-configured with the best optimal configuration. And given the devices with instant store are backed by NVMe Flash, this is an all-flash vSAN configuration. And AWS and VMware have done all of the heavy lifting off your shoulder in terms of certifying and qualifying and testing the device firmware, device driver running on ESXi, as well as the respective firmware for each and every one of the devices. So you will get provision each node with the vSAN ready node. So you don't have to worry about certification or vSAN ready nodes anymore. Okay? Now, vSAN data store, it has 2 data stores. One is the management data store for the virtual appliances such as the NSX Manager and vCenter Server. That's something you don't have to touch. That's managed and operated by VMware. The workload data store is one that you would deploy virtual machines on. That's where you would copy your virtual machine templates into. It's good music. And now, I mentioned we have done all of the undifferentiated heavy lifting off your shoulder. What you can focus on now is not device compatibility, but what storage needs do your applications have. For performance-sensitive applications, you could simply leverage the default vSAN data store policy and make at least 2 copies of data with RAID 1 mirroring. And if you have applications that are more capacity-oriented, meaning they need more capacity, then you could simply create another policy and specify, okay, I want RAID 5 or RAID 6 erasure coding, and simply apply those policies as you provision virtual machines at individual VMDK or vDisk level granularity. So this whole framework is called the storage policy-based management framework built into vCenter Server. And if you have the need for quality of service enforcement for your mixed workloads, then you could have the advanced capability added to your policy to specify the IOPS limits for your virtual machine vDisk. So all in all, EBS, Instant Store, storage services are integrated with vSAN and ESX, so we could do all the heavy lifting for you. So then you can focus on what's most important to you, these policies that will cater to your application needs. Okay, as we present to customers day in and day out, people really appreciate the simplicity and high performance of vSAN. And the next set of questions we get when it comes to storage is, okay, I have these applications and also user file shares that may not really need to take advantage of the extreme all-flash performance, but I have these multi-terabyte file shares that I need to run my application and user data on. What should I do? And our recommendation to that is the Amazon S3 back file gateway. So before we get into the file gateway, let's spend about 15 seconds talking about what S3 is. So it's our object storage offering is designed for 11 nines of durability. Okay, so we have multiple copies of data across our availability zones, a given region, and it's highly scalable with infinite storage capacity. So as a customer, you don't have to worry about how many files you're limited to put on S3 bucket. You just have unlimited capacity. It's highly scalable and highly available. We have 3 classes of storage in Amazon S3, standard for frequently accessed data, infrequent access for something like your backup file that needs to be stored for several months. And any longer than that retention, we recommend Glacier at the most cost optimized storage service. Now let's get into the Amazon S3 integration, a fresh reminder for what Artie had mentioned earlier. This is a slide I stole from Artie, and I just kind of moved the VPC at the end to make it different. The access path is from the VM through the NSX compute gateway over the Elastic Network Interface into the VPC endpoint for S3, and then into Amazon S3 bucket that you have configured. So this is the example I will use for the remainder of the presentation. Keep in mind the other mechanism of going through the internet gateway to access S3 in another region. So the best practice is to leverage the S3 VPC endpoint so you could access S3 in our private backbone network. Okay? The top use cases that customers have brought to our attention, like I mentioned, is file services. We'll go through that first, followed by the second top use case, which is data protection. How do I back up my data from on-premises environment into Amazon S3? As well as, okay, now I have migrated my workload into AWS. How do I back it up or restore them or test my restore? As well as, okay, now you have the elastic network interface, the high bandwidth, low latency connection between my virtual machines running on SDDC and my native AWS VPC, as well as services. How do I take advantage of your data analytics services and make meaningful graphs or charts out of huge amount of data? So we'll go over each and every one of these use cases in greater detail. I mentioned earlier, people love vSAN and its simplicity and its high performance, but for file share needs, we have a solution for our customers. So we have the AWS Storage Gateway, the file gateway, that provides a front-end interface that could export an NFS share to your Linux or your Windows virtual machines. So you could simply mount it as a regular NFS share in these guest OSs. The backend is backed by Amazon S3. So what that means is for the capacity question that customers ask, you could see the immediate relief from the customer's face when they see the file share mounted as 8 exabytes. There's no limit to Amazon S3 in terms of capacity. We just had to slap on an artificial limit, 8 exabytes. Okay. Now you could put your files in there and customers are happy to hear that, okay, I can address my capacity needs. The next question they asked me was, okay, what about performance? Even though I may not need all flash extreme performance, I still want my commonly accessed user data to be very fast when the users access them and when the applications access them. The quick answer to that is by deploying the AWS Storage Gateway, the file gateway on top of the vSAN data store, backed by all-flash vSAN solution. We have this notion of a read and write cache VMDK that is deployed with the vSAN default data store policy. And by default, you get the inherent all-flash performance for your most frequently accessed data, as well as write-back staging before they get asynchronously replicated to Amazon S3. So now that we have addressed the capacity and performance requirements, the next question we get then is, okay, we have these users that would, from time to time delete files accidentally. I'm sure that never happens, right? And people that would make accidental overwrites to files or removing specific contents within the file and still want those files back. Now, the answer to that is the simple enablement of the S3 bucket versioning. What that means is we capture every version of the files, which are having a one-to-one mapping between the file and the S3 bucket object. So different version can be retrieved based on what you need. So let's say someone deleted a file. You could simply access your bucket through AWS CLI or from the AWS console and say, okay, I want this version before the file was deleted, and give it back to the user. And there you go. So we have addressed the data protection requirement. Now, then the customers would be asking, okay, we have the capacity requirements, performance requirements, built-in data protection. What if I want additional copies of data in another region? Well, that could be addressed simply by enabling cross-region replication for your bucket and specify your destination region that you want additional copies on. All in all, you address all the customer's requirements. And the few things I'll touch on File Gateway is you can have up to 10 NFS shares. Each share is mapped to a specific bucket. So that's a one-to-one relationship. And the advanced AWS users that have used the service before would ask, okay, the Unix style permissions for my files, like read, write, execute, would those be retained? The answer is yes. We do not support symbolic or hard links for these files. What that means is we have additional metadata objects that will represent these permissions that you have set from the users, from your applications. And the file gateway is stateless by nature, so if it has anything that goes wrong with it, you can deploy another one. Your data is on the Amazon S3 bucket. That doesn't mean your data is gone. if your gateway has any issues. You just deploy another one with a few clicks in our AWS console and deploy that as an OVA that runs on top of your SDDC cluster. Okay, so now that we have talked about the file services that's backed by Amazon S3, the next use case that is brought up to our attention by our customers is that's been done by many customers is data protection, backing up virtual machine images as well as application data from on-premises infrastructure into AWS. So with that, let's talk about that. There are two main data protection use cases here. Backup to the cloud, and that's to the left, where you have your backup server writing to Amazon S3 or Glacier or different classes of S3 service in frequent access as another example. To the right is backup in the cloud. So typically when we talk to our customers and we talk about how they can migrate data to the cloud, the next question is, okay, I have my SDDC environment stood up in VMware Cloud and AWS. How do I back up my virtual machines then? So we'll talk about both in greater detail. Starting with the first one, like everything else we do, we want to provide customers with choices and flexibility. One of the ways to take backups from on-premises to the cloud is through storage gateway appliances. So these appliances are provided by some of the partners in our Amazon Partner Network, APN network. So some of the solutions I will highlight as examples here. So they either run as a virtual appliance if you don't have a huge amount of capacity, or physical appliance with more storage optimized capacity, larger capacity. So we'll focus on the backup solution. So I restrict the virtual machines to only the backup software architectural components and not regular virtual machines showing up here. So the backup flow goes like this. Are you all familiar with the vStorage API for data protection, VADP? Raise your hands. Okay, some of you are. So essentially it's the framework that VMware has for ecosystem partners to integrate, to perform backup integrations. So essentially what that works is if you have specific third-party software to perform backups, you have your backup server, which is more or less your control plane. You initiate backup jobs there, you configure backup repositories there, and you have something called the backup proxy. Right? What it does is the data mover, if you will. It mounts the VMware snapshot, hot attach it to itself as a VMDK, and perform copying of the VMDK snapshot into the gateway appliance. Okay? And the gateway appliance in this configuration is the example of the customer that has direct connection. Is, like Arti mentioned, is the dedicated 1 gig or 10 gig connection to AWS Direct Connect facility. High throughput, low latency link. Okay, so the gateway will have a route through the router BGP connection into DX, which stands for Direct Connect, and through the public virtual interface, it goes to Amazon S3. So your virtual machine image backups are sent to S3 this way. If you don't happen to have a Direct Connect service deployed for your on-premises infrastructure, then that's HTTPS traffic over internet. Some example configurations are the ones I mentioned, AWS Storage Gateway, and let's say the virtual tape library that works with many of the backup software solutions out in the marketplace. We have NetApp AltaVault, which is a virtual appliance or physical appliance that has native integration by migrating data into S3, as well as Dell EMC Cloud Boost that you could configure to work with Networker to perform image level backups, and it would replicate into Amazon S3. So these are a few examples of ecosystem partner solutions, as well as our native integrated solution. Okay. There are also solutions in our partner network that have native cloud connectors. What that means is the data mover, I mentioned the VM proxy, it has the ability to talk to S3 natively. So you don't have to have a staging area through a storage appliance before it goes to S3. So the flow goes like this. You have your backup server initiating a backup job. The VM proxy has the ability to talk to S3. Essentially, it would just mount the snapshot through hot add in the VADP framework, and then make data copying over Direct Connect into the public virtual interface into Amazon S3. Some ecosystem partner solutions that are integrated with S3 with a built-in cloud connector are the following: Veritas Net Backup as well as Commvault. Okay, now that we have our data backed up to the cloud, right, I mentioned earlier, we get often asked, okay, how do I rehydrate? Or how do I restore my backed up virtual machines into VMware Cloud on AWS SDDC cluster? It's quite simple. You just backtrack from how you got the data into Amazon S3 and rehydrate and restore them into SDDC. So the top one is the storage appliance approach, where you deploy another instance of the virtual appliance that runs either in the VMware SDDC cluster, if you have enough capacity and your backup data set is relatively small. Or you could deploy those virtual appliances or the file gateway in the customer account VPC, in which case you could have higher amount of capacity by using the more storage capacity optimized EBS volumes, which are often used by these ecosystem partner solutions. Once that's deployed in the customer VPC or SDDC cluster, you configure these appliances to talk back to the S3 bucket that was used for your backup virtual machine images. Essentially, you then make sure you export the shift or NFS share to your backup repository VM and initiate a backup restore job into another instance of vCenter server. As simple as that. Just very similar to how you restore, let's say, your backed up on premises to another instance of vCenter server on premise. Except this time around, the SDDC stack is running on top of AWS infrastructure, and you are within close proximity to your backup images because they all run in the same AWS facility. Now, the bottom one is where you have the native cloud connector that talks directly to S3. For those, deployment model is very simple. You just deploy another instance. Let's say for Commvault, you have another media agent virtual machine that you stand up in your SDDC cluster, point it back to the S3 up bucket that you use for backup, and initiate a restore job, and off you go. I'll give you a couple of examples of the ecosystem partner solution with, for example, Veeam and NetApp Multivault. So in this case, we have the customer on-premises data center to your far left, and then to the far right is the VMware vCloud VPC. That's where your VMware ESXi host and vCenter server, the SDDC stack is running. And then at the bottom, you have your AWS account VPC. And then, of course, your Amazon S3 bucket, which contains all of your backup. So the first step here is I'll draw your attention to the VPC at the bottom right next to Amazon S3. First step is you deploy, like I mentioned earlier, a virtual appliance, NetApp Multivault. It runs on regular EC2 backed by EBS for capacity optimized storage before they get replicated into Amazon S3. Okay, so you make sure then you configure the NetApp Multivault to talk to Amazon S3 bucket that was used for backup. And the second step is, I mentioned earlier, you deployed the data mover. In the Veeam context is the Veeam backup and replication console. You deploy this within a few minutes as a regular VM. I'm sure a lot of you that use Veeam would know how to do this. Then you make sure the data mover can mount the shift or NFS share that was exported from the NetApp Multivault. And then from your on-premises Veeam backup server, you would pick the data mover that was deployed in the SDDC cluster in the cloud and initiate a restore job. And by virtue of doing that, your backup images are getting rehydrated into SDDC. 4 simple steps. Now, we gave the example of the partner storage appliance solution. Now, let's talk about the ones where we have native cloud connector. Commvault is one example where they have native S3 integration. What you can do in this case is very similar in nature. You deploy step 1, the media agent in Commvault's terms. This is the data mover. Make sure your media agent can communicate with S3. That's the communication path for S3 using the S3 VPC endpoint example. And then second step, so say third step, is you initiate a backup restore job from your ComServe on premises. Or if you want, you could deploy ComServe in AWS SDDC cluster as well and initiate the restore. So step 4, rehydration happens and you get all your virtual machines back without any sort of conversion of formats or VMDK into EBS. None of that stuff. Is whatever you backed up is rehydrated as a virtual machine as they would run on premises infrastructure. Okay? All right, now we have migrated our data through the form of backup in AWS Cloud. The next question customers ask is, okay, I have my virtual machine workloads running in the cloud. How do I go about backing them up? One approach is, in the keynote, we mentioned Dell EMC solution is in the works for VMware Cloud on AWS. So what that looks like is for Dell EMC Data Protection Suite, there's Avamar, there's Networker. So you could deploy Avamar proxy and server as well as Networker proxy and server as virtual machines in SDDC cluster, and deploy a data domain virtual edition. There's an edition that's virtual that runs on regular Amazon EC2 with EBS volumes. You could deploy that through an AMI image, Amazon Machine Image, into your customer account VPC, in which case you can make the connection with your Avamar and Networker data mover and configure your backup repository. So backup flows, like Arti mentioned in her slide, from the virtual machine. Just imagine Avamar as the virtual machine you saw earlier. It goes through the NSX, the compute gateway, in which case it goes through ESXi host that's attached with the Elastic Network Interface, the high bandwidth, low latency connection into Dell EMC Data Domain Virtual Edition. And DDVE, as we all know, does inline compression and dedupe for data blocks before they get written to EBS volumes, providing you with cost optimization. And if you want additional copies of the original region, let's say in Oregon, you want additional copies in, let's say, another region in US East, North Virginia, you could deploy another instance of Dell EMC DDVE in the other region and configure replication at the data domain level to have additional copies of data. And you should check with your contacts if you use Dell solution about their integration with Amazon S3 in the future. Okay, here's another example. We talked about the restore using Veeam and NetApp AltaVault. This is how you would back up your data if you use Veeam in this architecture. You have your Veeam backup and replication console. You configure a backup repository and point your backup repository to a shift share that's mounted from NetApp AltaVault that runs either in SDDC or the customer VPC like the example illustrated. So it all depends on how big your data set is. Right? The NetApp AltaVault is stateless. If you run out of capacity, you could deploy it into Amazon EC2 with higher capacity if your heart desires. So do the planning ahead of time. And if you do have the replication from on-premises NetApp AltaVault appliance, and you'd want to deploy another one and point to the same S3 bucket for repopulation of the backup, be sure you follow the vendor's recommendation. For example, the set of steps are, number one, you pause the replication from NetApp AltaVault on premises. And second, you deploy this virtual appliance in SDDC or EC2, and you would then bring it up and enable DR test or DR mode. So you could repopulate your backups and feed it into the data mover that's backed by Veeam. And of course, we'll talk about the ones with native cloud connector. So in this case, it's the Commvault Media Agent. So if you have on-premises deployment of Commvault already, you have CommServe running, you have Media Agents running on premises, you could just deploy another instance of the Media Agent, point it to an S3 bucket you want to use in the same region, and off you go. Just when you do restore testing or do backups, make sure you select the right data mover. You don't want to traverse S3 to your on-premises infrastructure and restore back to VMware Cloud and AWS. So be sure you select the right data mover for Commvault. Okay, so we talked about backup to the cloud, restore into the cloud running SDDC, as well as backup in the cloud. The restore, I'll just let you do that as an exercise to backtrace the backup flow writing into S3. So we won't talk about those in great details here. What we'll talk about is another use case that was brought to our attention from a customer, a joint customer of AWS and VMware. This person actually was doing this on premises already with a Kinesis data streaming service. That's one of our data analytics service that they have the agent, Kinesis agent installed in a virtual machine running on premises and leverage Kinesis Firehose to stream the data and feed it into Amazon S3 and perform ad hoc query analysis using Amazon Athena. So I got asked the question, would that work in the VMware Cloud and AWS solution? And I said, I don't see any reason why not, because we have the route propagation that's done on behalf of you. There's high bandwidth, low latency access to our native services in your customer account VPC. So essentially what we have built in one of our 4 demos in the labs is based on what the customer had brought to our attention is, okay, I have these applications that generate a huge amount of log data. I want to make sense out of these logs without having to dig into them. How would I go about achieving that? One way to do that is you can install the Kinesis agent, simple install into the virtual machine that runs in your SDDC cluster. Then you configure Firehose, which essentially would take specific files of interest in the virtual machine that has the agent installed, and essentially feed that into Amazon S3 bucket or into Amazon Redshift for data warehousing, depending on what you desire. For ad hoc query SQL style analysis, you could certainly just have Kinesis Firehose feed into Amazon S3 bucket, and then launch Amazon Athena and start pointing to the bucket where your Firehose will ingest the data into. And then you can start running SQL query select star from certain columns. We'll build a table schema based on what we see in the data set in Amazon S3 bucket. And if visualization is your thing, then you could certainly just use a QuickSight and point to the Amazon S3 bucket of interest, and will allow you to create visual graphs, charts, histograms, pie charts, and you simply drag the columns of interest from the left to the right to populate these graphs to make sense out of data. And if data warehousing is your thing, then we have another choice for you, which is you leverage Firehose to ingest data into Amazon Redshift. Is our data warehousing service that you can stand up with a few clicks. So Redshift data warehousing cluster can be instantiated, and Firehose could feed that into the other endpoint. So essentially your data will be fed into a data warehousing cluster, and you can use SQL clients such as SQL Workbench to query against your data set for data warehousing purposes. So you go from just a huge amount of random application log data or performance stats into something like this. So I originally had a pie chart that I created for this session, and a few customers stopped by and I let them play with the service. They were able to create something that's nicer than what I created. So within a few minutes, I kid you not, come by the booth, check it out. We'll let you play with it, and you can make sense out of these randomly generated application data and get meaning out of it. Okay, so that is a wrap for the key storage integrations with Instance Store, EBS, Amazon S3, as well as the AWS Storage Gateway, and in particular, the File Gateway. Here are a set of key considerations that you have to keep in mind when consuming this service. For vSAN, it's all flash, high performance storage. You don't focus on certification of just device components and firmware. We take care of that. Every node is vSAN ready node. Instead, you focus on storage policies and cater to your application storage needs. For vCenter Server, RT mentioned, by default, is deny all for best security practice. If you deploy backup software in the SDDC cluster in the cloud, you want to make sure you configure the firewall settings to allow elastic IP address for vCenter Server to be accessible from the logical network that you deploy your backup software solution on. Very important. Otherwise, you will not be able to have the inventory populated in your backup software inventory mapping. Now, AWS Storage Gateway, we have very fine-grained access control lists. You could restrict access to your NFS shares with a specific IP address or CIDR block. And you have versioning that could be enabled for built-in data protection. And lastly, you could enable cross-region replication if you want additional copies of data from another region. Now, Amazon S3. IT mentioned IAM policy as well as S3 bucket policy. Keep that in mind. By default, S3 is configured with the best recommended security setting. You as a customer has a lot of choices and flexibilities to add additional level of security enforcement. For example, if you use S3 VPC endpoint, you want to add another policy to prevent access from any other VPC except for the one that you want your backup to run on. Now, access login, provides you with object level access information, who accessed the object when, for what operation, what the end result was. So you want to keep a trail of the access logs, specifically on the AWS Storage Gateway, for example, for your file shares. And also CloudTrail is a service that we recommend every customer to enable. So you have all the trail of everything that's accessing your AWS resources. Last but not least, there's a security token as a service, STS, and lifecycle policy that will allow you to have additional storage optimization and saving for your backups. If the backup solution that you deploy today does not have STS and lifecycle policy integration, I would highly recommend for you to talk to your vendor and make sure that is in their roadmap. Because STS automatically gives you temporary restricted access to Amazon S3 bucket. That means you don't have to do manual key rotations with the access and secret key pair that you copy and paste into the software, and take that heavy lifting off your shoulder. Now, lifecycle policy allows you to move data from standard tier of S3 into infrequent access. Infrequent access is ideal for backups as well as Glacier. So make sure your backup solution has those integrations so you don't have to do that on your own in the S3 bucket. So in summary, we talked about customer onboarding as well as a set of services that we have used for deep integration with VMware to provide simplicity for you. I'm not going to name every single one of these services. The point is, from onboarding to migrating your workload, to protecting your workload, as well as performing native AWS service analytics on these workloads, as well as many of our other services, we'll be there to support you, listen to you. So be sure to come by our booth and check out our demos. All these 4 demos are built based on customer feedbacks. So do come by and check them out. I have them listed here for Microsoft application, getting the best of both worlds, leveraging native services in your customer VPC, as well as SDDC to back your entire application stack, as well as running Oracle RAC on vSAN. A few clicks away, you have the multi-writer flag that can be enabled, allow you to run Oracle RAC on SDDC with a front-end application that's backed by Elastic Beanstalk for blue-green test dev deployment, as well as analytics I mentioned based on customer feedback. And the native service integrations, we have a session by my colleague Paul Bockerman, who happens to be here tomorrow. Be sure to check out his session. He will talk a lot about the additional services that we have to build custom applications that will satisfy all of your needs. And with that said, I haven't asked the 2 other questions for these swags. Let's do that. Okay, back there, how many nines of durability is Amazon S3? 11. All right. So come up to claim your price. On this side of the house. All right. What should I ask? Okay. What are the 3 different classes of storage for Amazon S3?
Standard, Glacier, and IA.
Yes. Okay. And with that said, do stop by our booth. This is not the last day we're here. We want to hear from you and learn from you and innovate on behalf of you. So we'd love to have conversation with you all. And I don't know whose shirt this is.
Thank you.
Thank you.